Hello and welcome to Code with Joe. In this video I will show you how to write a script in Python where we can buy token from Pancakeswap. And the great thing, this script also works on Uniswap. So how does it work? I'm going to show you here my code. So I have here my code, so the script. And when I run this script, we are prompted to enter an address, so a token address, and then we can purchase this token from Pancakeswap. So the token has to be listed on Pancakeswap for this to work, and yeah, but it'll work with every token on Pancakeswap. And what we do is we will use BNB to purchase a token. Okay, so let's get started. I'm going to show you this. Python.bypancake is the file name, and then when I run it, so now we can enter the contract of the token we want to buy, and I hit enter, and here we go. We get a transaction hash. And when I go back here to the blockchain explorer, I can paste in the transaction hash that I received. And then we can see that I purchased just right now 10 seconds ago from my address. And I spent 0.001 wrapped BNB, and I bought around 9 Yorkies. Okay. This is how this script works. As I said, the same script works on Pancakeswap because Pancakeswap is a copy of Uniswap, so it also works on Uniswap. I will demonstrate it on Pancakeswap. This is again Pancakeswap being a copy of Uniswap. So everything you see me do here, you can replicate this and do on the Ethereum mainnet. And the code that I'm writing here is really great because then we can use this, to build trading bots or anything else. So how does this work? So first thing, we have to look how a transaction works on Pancakeswap. So when I come here to trade, I go here to exchange, and then I can, so it gives me my balance in BNB, and then I can select a token that I want to buy. I'm just using the token that I just purchased. So my bad, I have to use the contract address. Okay, so no results were found to this token. This is strange. Well, let's just use a different token then. I'm just using here bunny token. This works with any token what I demonstrate here. So now I select the amount that I want to purchase, and then it gives me some a number of the amount of token that I can actually get for this price. So at the current price, I will receive X amount of token. So here we get a number. So 0.0, let me make it 0.01 BNB give me 0.149 bunny token. Now what I want to do is we click here on swap, and then our MetaMask, so I confirm here swap, and unfortunately you don't see that step. So my MetaMask pops up, and it should pop up with you too. And when you go all the way on top in MetaMask, in the first line it shows the chain where we are connected to, and the line below shows the account that makes the transaction to another smart contract address. And the smart contract address should start with 0x10. We can just click on it, and then we can just reject the transaction here in MetaMask. I dismiss this, and then I go back here to the Binance Chain Explorer, and I copy in this address here, the 0x10 address. This is the really important address here. And this is the Pancakeswap router address. So as you can see, whenever we do a trade, to purchase this token, we have to interact with the smart contract from PancakeSwap. And the smart contract looks like this. So we can go here to contract, and we can see here the contract of PancakeSwap. Then we can click here on read contract. And this gives us all the read functions. So it gives us a factory address, and it gives us the, in this case, again here, the code from PancakeSwap is a clone from Uniswap. So if you read here Uniswap, this, you cannot see this here in the code. Let me see if we find here something from Uniswap, because the contract here was originally written for Uniswap, but as I said, this is exactly the same. Actually, they rewrote their contract, so this is actually for PancakeSwap. It was written originally for PancakeSwap. Anyways, but this code, yeah, my bad. Now here it says Uniswap library contracts. Yeah, I was right. So originally it was written for Uniswap, but Uniswap, PancakeSwap being a copy of Uniswap, you know, it works here on PancakeSwap. So let's not get distracted here. What I want to show you is here the write function. So when we want to execute a trade, we have to interact with this smart contract. And when we interact with the smart contract, we have to call a function. And we can go here to, where is the function? So when we buy token, we call this for when we buy token, we call this function. So we enter swap exact ETH for tokens. This is my bad. This one is the correct one. Swap exact ETH for token. Yeah. So it says here swap exact ETH for token. Again, you know, being a copy Ethereum, it works the same way on Binance. So, and we enter here. Here it says BNB. Here it says ETH, but we can just enter BNB. So what we want to do, we want to swap exact ETH for token. So let's say we want to swap 0.01 BNB. Then we should get some amount of token. So this is just an approximate amount. Then we have to route this transaction to this wrapped BNB address. So here it says wrapped ETH, but this address is actually on PancakeSwap wrapped BNB. Go back here to my code. On here, so we have to fill in this form so we can swap exact ETH for tokens. So we have the price here. Then we enter the path. So the path is when we make a transaction, it always goes to wrapped BNB and then to the token address, so the contract address. This is the path we have to specify. So I paste in the first one being the wrapped BNB address, and the second one is the address of the token that we want to purchase. And I copy this one in here as well. Then we can specify here in the script where we want to send those tokens. So actually user A can purchase token for user B and send it to them. So we could specify this, but usually in PancakeSwap, when we purchase the token, we purchase it from our address and the token goes back to our address. So I'm going to copy here my address and paste it in here. And this is the last thing that we need, is the deadline. So this is when the transaction expires. So in some case the transaction gets stuck, then we have to specify a deadline before the transaction gets reverted. And we can use some epoch time. I don't know, what is epoch, current epoch? Something is 165. Hopefully this works. But as I just seen, I'm not connected here to Web3, so I have to enter everything again. Oh no, it stays. Okay, great. And then we can actually make the transaction. We call write and MetaMask should pop up. And if we didn't make any errors, is MetaMask not popping up? We are connected. How come my MetaMask is not popping up? So let me enter here the amount out minimum 0. Okay, now it pops up. And perfect. So again, you don't see my MetaMask, and I'm so mad about this. But if you followed along and the everything was okay, then you can see the confirm button, and then it gives you the transaction cost for the transaction to purchase the token. And then we can just click on reject, because we're not going to purchase the token from BSC scan. I was just showing you how to, what the fields are needed in order to purchase token from this smart contract. So we can reject MetaMask. And then we can actually start coding. So this is how we create the transaction here for PancakeSwap. And now we get here to, let me code this. So I'm having here my script. And I'm going to delete everything. If you want to do it the same way as I did it, I created my project folder. In my project folder, I have a virtual environment, and in this virtual environment, I have, actually we only need 1 or 2 files for this project. The main file is where we write the majority of our code, is the in my case, the pancake.py file. And I also have a config.py file. This holds the private key to the address where I want to purchase tokens from. And once you have set it up the same way as me, then we have to install one library. This is the web3 library, and we can install it with pip install web3. And once this is done, then we're actually ready to rock and roll. What web3 is basically a glue between our script and the blockchain. So we call, when we write functions in our script, we call it through the web3 library, and then it's being executed on the blockchain. Okay, so this is basically what web3 is in a nutshell. And yeah, let's get started here. So I already prepared my code here, of course. So the first thing that we need to do is we need to make our imports. So for this project, we importing web3 from web3. Then we import JSON. We import config. So if you have your private key in a separate file, you need to import this as well. In my case, it's the config.py file, and I import it with just the file name import config. And then I also, if you want to automate this, and for the deadline, we need to import time. And then we can already connect ourselves to the blockchain. And we're using here the Binance Smart Chain. If you were to do this on Ethereum, then instead of using the node here from Binance Smart Chain, you have to use Infura. The rest is basically the same in the whole script. And then we can save this here. So with Web3, we initiate the connection here to the blockchain. So this is the node of the blockchain, and then we create an object here using the HTTP provider and the node. And then we can test if we are connected. So I'm going to run this here. And when we get here as answer true, then we are connected to the blockchain. Perfect. So the next thing is that we need to do is, because we are interacting with a different smart contract, so we are interacting with the PancakeSwap routing contract, we have to import, so we have to create an object for this contract so that we can call these the functions on the smart contract. And we can do this by specifying first of all the PancakeSwap router address. So the contract address for the PancakeSwap router is this one, the 0x10. This is also being used, this address, when newly tokens are being listed on PancakeSwap. So yeah, if you want to make a bot, a sniper bot that picks up freshly created token, so freshly listed token, this is also the address that you want to listen to. So I'm going to go back here. So I'm going to create here the variable for the address, for the contract address. So I call it pan router contract address, and this is the address that I just shown you here from BSC scan. Then the next thing that we need in order to interact with the contract, we need the smart contract, so the API of the smart contract of the PancakeSwap router. And I have it here in my notes, so 1 second, I just copy this. And this is the API, and you can get the API from BSC scan. So when you go on contract here, click on code, then you have the contract source code, and what you need is the contract API, and you can just copy it by clicking on there, on this icon. So what happened here? Okay, so we got the contract API and the contract address. The next thing that we need to specify is the sender address. So this is going to be my address, so the address that holds BNB, and from this address we purchase the token through PancakeSwap. Then the next thing is, or actually we can look up the balance. So what we can do first, is since we're connected, we can look up the balance of the sender, so the BNB balance. I'm going to run this again, and then it gives me the BNB balance in way, and we can convert this easily into something human readable like this. So I convert the balance into way, so actually into ether. So this is what we got. The response here, it was in way, and we convert this into ether, and then it's more, so it's human readable. So let me save this, run it again, and now we can see my BNB balance in a human readable format. So the next thing that we need to do is we need to create a contract instance. And we can do this like this. So we create here a variable and we call it contract. And then we create here a contract instance with web3.is.contract. And then as address, we specify the Pancake router contract address. That's the one we have up here. So this variable. And then we have the API, and the API variable name is pan API. And then, you know, we can create here a contract instance. And once we have the contract instance created, then we can actually call these functions on the smart contract. So all of these functions here, the right function. So we could, on the routing address there, we can add liquidity. That's why I just said earlier, you know, whenever somebody lists a token on PancakeSwap, this is the contract address, the 0x10, the routing address, and this is by adding liquidity. This is the function that they call. Then we also have remove liquidity. We have, what else do we have? Add liquidity in Ethereum, add liquidity with both tokens, so in token A and token B. Then we can also remove liquidity, so the Ethereum that we added we can remove. We have some other options on how to remove liquidity. Actually 8, 9 functions of them is only for liquidity. And then we have the functions to swap token for Ethereum for token. So swap ETH for exact tokens, meaning then we have to specify the exact amount of token that we want to get out. Here we have to specify, this is the function we use, we have to specify the exact Ethereum for tokens. And this is some function with supporting fees. I'm not sure exactly what this does, I've never used this before. And then we can also do it reverse, so we can also, when we want to sell our tokens through PancakeSwap, we would have then to call this function swap exact tokens for ETH and specify, you know, all these fields here. Then we have the same with the fees, etc. Here is some more with the fees. So this was with fees, this was with fees, and this is swap exact tokens for token. So if you want to swap pancake token for bunny token, you know, we would call this function here. And swap tokens for exact ETH. So this means we want to specify the exact amount of ETH that I want to get out of the contract. This would be this function. And swap tokens for exact tokens. And this is again when we want to swap two tokens with each other. But we stick today with this function here. And as I said, we have to call here all these, so we have to fill in these 4 parameters here in the function, and we can do this like this in our script. So let me go back here. So we have our contract instance. The next thing that we want to do is I just copy this here from my notes. So we also want to specify the token that we want to purchase. So in this case here I have two options. We can either ask for user input, that is one that I demonstrated, where we manually enter the token address, or we can also just hard code the address into the script. So this would be the token address here. This is important. Then also another important address, of course, is the wrapped BNB contract address. So because every transaction, so when we buy a token with BNB, of course all the transaction routes through BNB, and so we have to specify here this the address, the BNB wrapped BNB address, because BNB itself doesn't have an Ethereum address, at least not on the Binance Smart Chain. So, you know, we have to wrap the BNB into, so the BNB we have to wrap it into wrapped BNB, and this is the contract address. So then the next thing that we do is we need to create a transaction. And in order to create a transaction, or to build a transaction at the end, is we need to get the transaction count. And I'm going to call this before we run the script. And this is called the nonce. And this is basically when you open up MetaMask, then you can find somewhere where it says nonce. But this is nothing else but the transaction. So how many transactions that you had already on this address. And we have to specify it. We can do it by like this. Nonce is web3 .eth.get _ transaction _ count. And then of course we have to specify the address. So the transaction for the address that we want to get the count from. And this is the sender address. So this is in my address. So the next thing is because we need the deadline when we call the function. So we have to specify it with time, so that's why I imported the time package up there, and I just call it here start is time.time, and this is the current time that, you know, when we run the script. The next thing is, then we actually need to create here the so we need to set the parameters here for the transaction. So we call here, I create here a variable, I call it Pancakeswap underscore transaction, and then we call on the smart contract, we call the function with contract.functions.swap exact ETH for token. So it has to be the exact function name in order to, you know, to call it. And then we have to fill in these fields. So the first field was swap the exact tokens for ETH. So there is, let me go back here. So the first one was swap exact ETH for tokens, but since we're buying the token with BNB, I can, you know, specify the value when creating actually the transaction. So we're not going to use this one here. What we do here is the first one is the amount. So this, you know, we can look up, let me show you. We can actually look this up manually. We can leave it here at 0. But when we want to do a transaction here, we get an estimated amount for the transaction. So, you know, this is basically this amount here. You know, and we can say, if, you know, if we get less when we run this transaction, and, you know, we get, would get less than 0.139, you know, then we want the transaction to revert. So this is where we can specify it. Well, we can just leave it as it is, as 0. And then we have to specify the path. And the path we specify in our script like this. So the spend is of course the first address of the routing contract. So this is the wrapped BNB contract. So this is was specified under spend. Then we have the token to buy. So this is the second address. So this is actually the contract address of the smart contract, those tokens we want to purchase from. In my case, it's the 0x666. This token that I created a while ago. Nobody bought it, so it's a dead project. But this is the address that I'm going to use here. So I have it here in my token to buy variable, and in Pancakeswap we have just pasted in here the contract address. This is the path that we are writing right now. Then the next thing is, of course, where we want to receive the tokens to. So where the, you know, once the tokens are purchased from the smart contract, we want to, you know, specify the receiver in case the receiver here is also the buyer. So I want to, you know, I spend my BNB and I want to get back the token to my address. But as I said, we can specify a different receiving address. And this is this one right here. And the last thing is the deadline. As I said, we have to specify a deadline. For some reason the transaction gets stuck or whatnot, you know, then we can specify the current time. So I have here the current time as start, plus we add here 10,000 milliseconds. And then we have here filled out everything for this transaction. So what we want to do now is, here on the website we click write, and then MetaMask pops up, and we, you know, we can see the details, the gas fee and the total amount, and then we confirm the transaction in MetaMask, and then, you know, the transaction is being you know, basically, so we once we click confirm in MetaMask, then we actually purchase the token. But since we don't have MetaMask in our Python script, what we need to do is, instead of having MetaMask sign our transaction with our private keys, we have to sign it ourselves with our private keys in our script. And we can do this by adding something onto our transaction here, to the Pancakeswap transaction. And this is actually the build transaction. And I just paste it onto here. And so we have here the build transaction function. And here we need to specify from. Of course, the from in my case is the sender address. Then we specify the value. If we, because when we write a script and we interact it, by default, everything is written in way. So in order to make it human readable, we have to convert this. We have to use the web3.to way function so we can, convert it easily to something human readable. Now I'm going to change this to 0.1. So I want to spend. So this is the amount that we want to spend. So this is, oh shit, you didn't see, God, it happened this again. Yeah, so all I did was I copied here the build transaction from here to here. This part I just copied and pasted. So and this has, in the curly braces here is the parameters. As I said, the from address is our address here. The value, again here, I say it again here, we have to convert it to way, because by default, if we not use the function, we would have to, if we want to send 0.01 ether or BNB, we would have to write a 1 and then 16 zeros. So with web3.way, we can just convert it to human readable format. Then we have to specify the gas price. Since, usually MetaMask would do this for us, but, in a script, we don't have MetaMask. And we also have to set the gas price. We hard code the gas price because on Binance Smart Chain it's kind of cheap, so this setting works. And then the last thing that we have to specify here, this is important, we have also to get the nonce, and this was the part up here. This is the transaction count. And once everything is done, then we're still not done. We have to sign the transaction. And this is now when we need our private key. So this is, in my case, this is where the import.config comes into play. So I have here my private key for this address in the config.py file. And then I imported it in this line here. So we sign the transaction. So we create a signed transaction variable. And then we call the sign transaction function with web3.is.account.signTransaction. And then we paste in here the Pancakeswap2_transaction. So this was the transaction we just created up here. And then we sign this transaction with our private key. So if nobody sees your script, you can get away with just pasting in your private key like just pasting your private key like this. Or you do it like me, with having the private key into a separate file, import it into the script, and then using referencing with config.private to the private key. So this is up to you. And then once we sign the transaction, then we actually need to send the transaction, and we can do it like this. So we create another variable, we call it transaction token, and we sign the transaction, so with web3.is.send_raw transaction, and then we pass in here the signed transaction that we just signed in the previous step, and then we call the raw transaction function on this. And the last step, then we are done, is that we want to get a confirmation if the transaction was successful. So we can print out the transaction hash like this, and we want to convert the transaction token, so the transaction hash that we get here, the raw transaction output, we want to convert into hex, and then we can just take the hex response and then just paste it into Binance chain and look it up. And this is what we're gonna do right now. So if I didn't screw anything up, we should be able to purchase some token now. And the token address, so I'll paste in here the address, enter, and we get a transaction hash back. Now let me copy this, and here in BSC scan, if I scroll up, then we can find the transaction details, and from this address, this was this Panda address, so my address, we interacted with the routing contract, and then we got from the PancakeSwap router to V2, got some wrapped BNB, and then we got, so the PancakeSwap router sent back to this address here, you see it's the same, 91 Yorkie token. And when we click here to see more for the transaction, we can see the input data, what function was called, and over here when we decode the input data, we can actually see the amount in, so I didn't specify any data here. Then the path that we selected, so we first of all we routed through the wrapped BNB address. So if you pay attention, this is the wrapped BNB address without the 0x, and this was the address of the token that we purchased, also without the 0x, and then it was sent to the DCC20 address. As you see, this is my address here, and then was the deadline, we specified some deadline, and this was the whole transaction. And now let me click on my address here, and we have here some Yorkie token, and as we can see here, it took me about 1 minute to explain all this, and this was when we received the Yorkie token. And this works for basically any token that we want, so I can just demonstrate this with grabbing any other token here from CoinGecko. I'm just going to buy SafeMoon token like this. So I got here the SafeMoon contract address, go back to my script, and I run it again because we have to enter the contract address anyway, so I don't even have to change anything. Run it, and then we enter the token address, so I paste in the address from SafeMoon, hit enter, perfect, and we already get back our transaction hash. Copy it back to Binance chain, paste it in. Oh, and it failed. Oh, what happened here? What happened here? PancakeSwap cancelled. Oh my god. Now this is always one of the greatest moments when you make a video. You think you're so sure that it worked, and then all of a sudden it fails. God damn it, what happened here? Yeah, so I'm not sure what happened. Why the last transaction failed here. I tried here another one. I tried to buy Bunny token now, and it did go through. I can show you this here again. I'm just going to run this transaction here again. So, and I paste in here the contract from. Oops, that was not the contract. That was the transaction hash. So let me grab the Pancake Bunny contract address here real quick again, and I paste it in here, run it. Okay, I get a transaction hash back. Let's go back here to Binance Smart Chain here, Explorer, and here the transaction went through actually. I don't know what happened, why I wasn't able to purchase SafeMoon token with the script, but yeah, I don't know. I'm going to end this video here because it's getting too long, and I will work on a fix on why it doesn't work for PancakeSwap. And yeah, It works for any other token. I can try here another token here to show you this. I'll just use a recently added one. Scooby-Doo. Let's buy some Scooby-Doo token. Okay, this is on Ethereum. Palestine Finance, I already have this token here. It was doing really good, this token here. Actually, I'm just going to buy one through my script here. And I run it here again, and it should work on this one as well. So paste in the contract, and we get a transaction. So let's go back here to BSC scan, and perfect. So this transaction also went through. So I don't know what happened here with the SafeMoon, why I can buy SafeMoon with this contract, with my script, but it works for any other BSC scan token. Okay, also the script is on my GitHub, and the link to everything is in the section of my in the below the video, in this comment section. And also, before I forget here, this is just a thing in here, a notification here for where's my YouTube? So when you come here to my channel, I see a lot of scammers are in the comment sections here. So close this. So when you see some comments, okay, now you don't. Oh wait. That looks like there's a scammer back here. So yeah, here this is the one. So if you see a message like this here, thanks for watching, and WhatsApp, there where somebody leaves a WhatsApp. I do not have WhatsApp. I do have WhatsApp, but nobody knows it, and I'm not using it. And this is not my channel name. If you see, there is a little thing on top of the O, and if you click on this, on his channel, then you come to his channel and you see he doesn't have any content. So don't fall for this. And if you see them, please report them. I also report them all the time. I don't know, I hide them from the channel, and they still come back all the time. But what they do is they always change the username, add some little thing here. They also added a comma at the end, so a dot at the end. So yeah, just if you see them, please report these scam comments here. They are under every comment. Yeah, here we go. And some more, and some more, and some more. Yeah, do not fall for this. Here he has another one, and this is a different account. So this one has the little thing up here above the O. This account has the little thing completely tricky above the I from WizJoe. So somebody is really putting work into, like, trying to scam people here on my channel. So yeah, guys, please report these comments if you see them. Alright guys, that's it for this video, and I'll see you guys in the next one. Bye.